Hello, I welcome you all to this another interesting screencast. The problem reads, the 80 pounds ball is suspended from the horizontal ring using 3 springs, each having an stretched length of 1.5 feet and stiffness of 50 pounds per feet. Determine the vertical distance h from the ring to the point A for equilibrium. This particular problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so we have a ball being supported by 3 springs and each having a stretched length of 1.5 feet, the stiffness of 50 pounds. So one thing to observe in this particular problem is symmetry. Symmetrical about the vertical, we'll call it z-axis. It's not there, we are going to show it, and therefore we expect, let's call this as B, C, D. So force AB is going to be equal to force AC, which is equal to force AD, which we are just going to call T, which we are going to prove when we apply the equations of equilibrium. So let our reference in this case be A as our 0, 0, 0. So let's draw the reference system at A. Let this be our our y-axis. This one be our y-axis, and then this one somewhere here, maybe I want it to be something like that. Okay, how is that? It's okay. So that one as our x, and this one as our z. So let's label it. So we are saying this is y. All right. This is y. This is x. So let's label our axis. This is y. This is x, and this is z. All right. Of course, we have C there, we have D there, and then we have B there. Great. So what we need to do is, let's section these particular forces. We do a section here, we do a section there, we do a section there. All right. And once we do so, then we expect a force here, like so, and a force there. Okay. Another one there. Okay. And then we expect a force there. Okay. Then there. Okay. And then there. Okay. And then there. Okay. Right. So we have all these forces. So let's call this as our AD. Okay, this one as our AC, and this one is our AB. Okay, so let's indicate, of course we said there's symmetry here, so let's just show the angles. We are going to have this component here. Let me just show it. This one here, okay, this one is a line perpendicular to parallel to the x-axis, right? Something like that. What else? Of course, we have the y, and then we do have this here. Okay, let it just go straight. Sorry, I think let it just go straight like so. Go straight like so, something like that. Great. All right, so we have those angles here. So this angle here, so if this is 90, if this is 90, this one here, if this is going to be 90, this is 90, then we expect this to be a 30, right? Which is 120 minus 90. And if that is the case, this also is going to be 90 here. All right, this is also going to be 90. So we expect this to be equal to this one there, to be equal to this one, to be equal to what will be this one? That's 120 minus 90, which is a 30. This is also a 30 here. Okay, so with this information we can now start drawing our system, the components. So we are going to have a component. Let's start with AB. AB will have it's just in the Y. AB is in the YZ plane, so it will only have one component in the Y, of course, and another component in the Z. Okay, let me take it up to there, somewhere there. I'll take it up to somewhere there. All right, up to somewhere there. Okay, and then let's go to AC. AC, it will have a component in the negative X, like so. Let me take it up to there. Not too good. Let me move out these. I'll write them later on. Let me extend this. I take this up to there. Okay, and then I can write down this now. So we said this is AD, and so is this one there. All right, and then so we'll have a negative, and then we'll have a positive along the x-axis. All right, and then we'll have another component along the z-axis. All right, and then finally we have AC. AD. AD, it will have a positive along the x. It will have a positive along the x. Along the x, a positive, and then it will have a positive along the y, and then it will have a positive along the z. All right, let's label this because we are done. Let's start with AB. So AB, this one is just AB. Let's find the length. We didn't find the length, so length AB is equal to length AC, which is equal to length AD, which just is equal to L, which is equal to square root over h squared plus the radius of our ring is 1.5, right? So it's 1.5 squared. So L therefore is just going to be equal to 1.5 squared. So this just becomes 2.25 plus h squared. Great. So let's label this. So AB is just going to be equal to, so let me call this as L star. Alright, so that I don't write the whole lot of this too much, let me just call it as L star. So this is just going to be equal to point, the length along the y there is 1.5 divided by the length, which is just L star. Alright, I want to use blue, so 1.5 divided by L star. Okay, and then this one is AB, which is just H divided by L star. And then let's go to AC. So AC is just going to be equal to 1.5 divided by L star, and then we are going to map it, right? We are mapping AC on the y axis like so. Okay, you see this? So we are mapping it. We have this angle 30 degrees with the x-axis. So if you have to map it on the y-axis, then we'll say sine 30. Okay, and then finally this one is just going to be equal to AC. This is just AC H, okay, divided by L star. Alright, and then this one is just AC by 1.5 divided by L star, then times, we are also mapping it on the x-axis, right? So this becomes cos 30 degrees. Alright, and then the other one, we have this one, which is AD 1.5 divided by L star. So AD, you're mapping it on the y-axis, we have to sine it. So sine 30 degrees. This 30 degrees, this one here. Okay, so we are talking about this one here, right? So we are mapping it on the y-axis like so. Okay, and then this one is AD by 1.5 divided by L star, and mapping it is just a cos 30. Okay, and then this one is just AD by H divided by L star. And finally, we have the weight of our ball, which is just 80 pounds. Have we left out anything? Don't think so. To just create space, let me move this. Let me move it here. Okay. Let me move this one here. So we say this is AD by 1.5 divided by L star, which is in the y-axis. So in the y-axis, this becomes sine 30. Great. So let's apply the equations of equilibrium. So we'll start with summation of forces in the x equal to 0. What do we have in the x? In the x, only have 2. So I'll start with AC. So I'll say 1.5 divided by L star AC cos 30. This is a minus, then plus 1.5 divided by L star AD cos 30. It's also equals 30, right? equal to 0. So when you look at all this, everything else will cancel. Therefore, you expect AC to just be equal to AD as initially predicted because of symmetry. Then summation of forces in the Y. Summation of forces in the Y. What do we have in the Y? What do we have in the Y? Let's start with AB, which is minus. So minus 1.5 divided by L star AB. Then plus 1.5 divided by L star AC sine 30 and minus 1.5 divided by L star AD sine 30. Sine 30 equal to 0. So again, when we look at this, when we sum up all this, of course, all these parts, they go. Sine 30 is 0.5. So we know that AB is just going to be equal to half AC plus half AD. But we know that AC, we have to replace AC there, and this just becomes equal to AD. Alright, therefore we have proved that AC is equal to AD, which is just equal to AB. Okay, great. Then we go to the equation that should give us what we are looking for, summation of forces in the Y. So we've called this T, so we can just say this equal to T. So there are three of them. We'll just say 3T times H over L star, okay, positive, then minus 80 pounds equal to 0. Alright, so these are all springs, so we can write this T using using Hooke's law, which is just Ks. Alright, okay, L final minus L original, and we know that L final, we just calculated at L star, so this is just going to be equal to 50, which is the stiffness, times L star minus unstretched length. They told us is 1.5, right? Remember the unstretched length, this one here. Alright, so this is the whole expression, so we can write this as just 3T. 3T is just 3 by 50 by L star minus 1.5, okay, then times H divided by L star equal to minus 80 equal to 0. So if we simplify this further, it becomes a 150 H, okay, 150 H, then minus 1.5 by 150, which just becomes a 225 H divided by L star minus 80 equal to 0. Alright, so now Let's just create a boundary here so that we finish off what we've started. All right. What do we have? So writing this equation, we just have the following. We have 150 150h 150h minus 225 h divided by L star, and L star we just said this is root of 2.25 plus h squared minus 80 equal to 0. Okay. How best can we work on this? Okay, let's simplify this further. So this can become h. We factor out h, then we say this becomes 150 minus 225 divided by root of 2.25 plus h squared, okay, minus 80 equal to 0. Alright, so how do we solve this? We can solve this using a number of methods. I'm going to use a trial and error. So I'll say let my function be the function of h, alright, where I have h 150 minus 225 divided by 225. So this is my function. This is my function. So I'll say let this be my function. Let me just redraw this. I draw this boundary here, something like this, something like this. All right. So this is the new boundary here. So I'll say let this function be function of h, like so. This is not the only way to solve this. Then I'll have a 150 minus 225 divided by root of 2.25 plus h squared, okay, minus 80 equal to 0. So we are going to go on the number line like so. We have negatives and positive. There will be a value of h that will give us a negative. There will be another value of h that will give us a positive. Then somewhere in between, that's where our solution lies. Okay, so we're just going to be iterating. Great. So it's important to choose your domain, the values of h that you're going to try. So we'll say h is from 0 to, again, the upper value in this particular case, you can make any judgment, any value, okay. It doesn't really matter because the idea is to find a value that gives you a positive, value of h that gives you a positive, and another value that gives you a negative. Then begin now to iterate between those two values. So let's say from 0 to 5. Okay, 5. So this is our domain of the units are feet. Alright. So let's draw a table, then we start doing the iteration, and then we should be able to compare it. Again, this is one of the alternatives. Alright. This is not the only way. This is just one of the alternatives. Alright. You can use other alternatives. You can simplify this if it makes the work easier and work it out. Alright, so let's say we have h there and then we have the function of h. So let's try 0. So when we have 0 in there, then we just expect a minus 80. Let's say we have a 1. If we have a 1, then we'll have 150. We'll have a 2.25 plus 1 squared which is just 1 root of that. Okay, 225 divided by that, plus 150, and then minus 80. So we still have a minus 54.81. So 2.25 plus 1 square root of that, 25 divided by answer, and plus 150 and minus 80. Okay, so let's go to 2. 2, so we'll have 2.25 plus 2 squared, the root of that, 225 divided by answer, and then of course 150 and by 2 and minus 60, then we have a 60. Alright, let me repeat this. 2.25 plus a 4 square root of that, 225 divided by answer, plus 150 by 2 minus 80. Okay, have a 40. Come on. 225 plus 2 squared, square root of that, 225 divided by answer, plus 150 by 2, minus 80. Okay, it's a 40, right? Of course, what we find, okay, so we know that the solution lies between 1 and 2. So get the average of the 2, which is just 1.5. We'll feed it in the equation. So 2.25 plus 1.5 squared, square root of that, 225 divided by answer, plus 150 times 1.5 and minus 80. We have a minus 14.09. So again, we get those with the lost values, negative and positive. That's a 2 and 1.5. So average of that, what do we get? We have a 1.75. Let's plug it in. So 2.25 plus 1.75 squared, square root of that, 225 divided by answer, plus 150 times 1.75 minus 80. So of course, so slowly we are converging. I know maybe this method is annoying. 1.5 plus 1.75 divided by 2. So we have the average of the 2, which is just 1.6 to 1.63. If I rounded off this value, is this value. Alright, so 2.25 plus 1.63 squared. Okay, square root of that, 225 divided by answer, 2.25 plus 1.63 squared, square root of that, 225 divided by answer, then we have plus 150 times 1.63 minus 80. Alright, it is converging faster, which is cool. So again, we get smallest values of the two. So 1.75 plus 1.63, average of that, so 1.69. Let's plug it in. 2.25 plus 1.69 squared, square root of that, 225 divided by answer, okay, then by 1.69 minus 80. Alright, a 5.22, average of that, 0.63. So we continue doing this process. Can use a computer for this, but you just need to know how to do it by hand also. 1.66, we do the same, plug it in. 2.25 plus 1.66 squared, square root of that, 225 divided by answer, times 1.66 minus 80, which is a 2.06, and then we get the smallest values. These are the ones, which is 1.63 plus 1.66 divided by 2, 1.64. So 2.25 plus 1.64 squared, okay, square root of that, 225 divided by answer, plus 150 times 1.64 minus 80. So this we have a 0.03. This is good, this is cool. You can get another iteration if you want to. You see how this is going to behave. 166. Again, you are getting those with the smallest value of negative, smallest value of positive. Alright. Okay, by 2, that's 165. Alright. 165, let's plug it in, we see what happens. 2.25 plus 165 squared. 2.25 plus 165 squared, square root of that, 225 divided by answer, then plus 150, then by 165, then minus 80, we have a 1.01. Okay, if we got the average of this, 1.64 plus 1.65 comes back to either 1.64. So it's going to be iterating between the two, so we get the minimum. Okay, so if you get the average, we get the 1.65. okay, who get this? So this has a minimum value, right? This has a minimum value and the error also is small. Okay, and therefore our h is approximately equal to a 1.64. okay, 1.64 feet. Great. So determine the vertical distance h from the ring to the point F for equilibrium. Right. So this is what we found, and let's just outline the final solution like so. Okay. Right. So we are done. And I hope the video was helpful. And if it was, give me a thumbs up, like my video. Continue subscribing and liking my channel. Bye bye, and see you in my next screencast.